Good morning, everybody. Thank you for coming. I know it's difficult after the party, and also excuse me for this truck driver voice I have. Um, my name is Alvaro Sanchez. I'm a developer. I live in Madrid, Spain. I've been working professionally in Java since 2001. I happen to work for BA and for some microsystems. And I got to know Groovy and use it extensively since 2007. I also contribute to several frameworks like Grails or Ratpack. I also like to speak at different conferences. If you don't know me about this, maybe you know me about this one, because this is the very famous slide that I've been talking about, and is the most concise definition of what a microservice is. So yeah, it's the same shit, but in smaller pieces. This has been very popular. It's insanely popular, more than I expected. So a few days ago, I asked on Twitter how many people would be willing to buy a T-shirt or a mug with that picture on it, and it's like 45 retweets. So I have this for you. This is a crappy QR code, so you can scan it and it will direct you to the tweet. So go grab your phone and scan it. You can retweet if you like the picture or not. The QR code works, by the way. Doesn't ask me why. Does it work? I tested myself and it does work, but maybe the resolution. Never mind, this is just a joke to make your morning more entertainment. All right, so I work for a company called For Finance. We are in the financial industry, despite the name. So it's all about loans and personal budgeting, payment systems, and anti-fraud and risk systems, all that sort of things. We use Spring Boot, Gradle, Java 8, Groovy, Jenkins, Ansible, and many other things. And there is always positions available in Warsaw, in Prague, in Riga, and buildings in London as well. So for financeit.com if you want to check it out. All right. So the agenda for this session is, an introduction. Then I will tell you about the handle chain, how that works, the context, a little bit about the Ratpack modules, then some words about the asynchronous model of Ratpack, and finally some questions. The slides are available already in that URL. Actually, probably it's not the latest version, but you can search for my name in the slide here and you will find them. There is some code, accompanying code for this talk of the demos that I will show you. That is on that URL, and finally, there is a workshop version of this talk on that URL. So don't try to copy anything because it's everything published on GitHub. If you happen to learn more about Ratpack, there is this afternoon at 2 p.m. on Trackstreak, Andre, which is here, is giving you a workshop about Ratpack, so go there. So before we start, raise your hand if you know Java or use it daily. Yeah, obviously. Groovy. All right, the other ones can leave the room. Spock for testing, very few. And Ratpack, yeah, two. You use Ratpack? You know it. Good. That's the I use Vertex. Who else use Vertex here? Only you. You can leave the room now. No, I'm kidding. I'm kidding. Nice. So what is Ratpack? Ratpack is essentially a Java 8 library or set of libraries. They don't like to call it a framework because a framework sounds like too much. It is lightweight, very lightweight, you will see it. It is unopinionated, unlike other frameworks. It doesn't have opinions on how you should use it. Although there is a little bit of conventions and best practices, there's not much. It is native-based. I'll tell you what that means later. It is meant to write non-blocking HTTP applications. Focus on performance and efficiency, with an emphasis on testability, and you can use Java or Groovy as programming languages, so it's your choice. When can you use Ratpack for microservices is the word of the year. But also when you need like high performance applications that need a high throughput, a lot of requests per second. When you just want to build like lightweight services, they call this like no batteries included because you don't need anything else. You don't need a container. Everything is included. And this is a personal thought, so everybody is talking about microservices. So if you are into microservices, why do you use macro frameworks, right? Like bigger frameworks, much bigger frameworks, and I look at that use Spring Boot. So Ratpack is really developer friendly, and if you compare this with Vertex, for instance, there are some similarities. There are some things that are not similar or different, but I think it's much more developer friendly than Vertex. So the startup is in milliseconds. You'll see that later. So if you compare that with Spring Boot, like a brand new Spring Boot application takes 3-4 seconds, more or less. Brand new Ratpack application is milliseconds. It's really fast, but also it's like it's fast because there's much less inside. You have development time reloading that again takes milliseconds, thanks to Gradle. This used to be using something called Spring Loaded in the past, but in the latest version they are basically using Gradle continuous integration, reloading feature. So when you run Gradle -t, Gradle will basically scan your source folder, and when something changes in that folder, Gradle will trigger a rebuild of the project. So they basically are using this, and that's all. It just works. There is first-class support for functional testing. I think this is important. And when we're talking about HTTP applications, functional testing means you have to spin up an instance of your application and make HTTP request to it, right? This is really easy with Ratpack. Okay, so let's go to the demos. Can you see the shell? This is the most basic example of a Ratpack application. This is simply Groovy script. We're using here the add grab annotation. The add grab annotation in Groovy is an state transformation that will, as you might infer, will download the artifacts from a Maven repository. and make that available in your class path automatically. It's really handy. And when you see here, what you see here is essentially the Ratpack Groovy DSL. There is DSL to define the handler chain that I will explain later. So we can run this. There is no, I don't know if you saw when this icon appeared here, but it's basically when the server started. So if I open a new shell, we have hello world, right? There's nothing in it. So basically, I can say like this one, and I get the string I pass. This is the most simple handler definition. We will explore that later on. I'm defining this, so whenever I have something here, I'm capturing that as a variable, and I use the variable later on. And otherwise, when I don't have anything, just hello world. Obviously, a Groovy script is a viable solution for demos or really like short-lived applications. But if you want to do something real, this isn't an option. So fortunately, you can use the Gradle build for that. So this is how like normal, well, I'll clean this. This is how a Ratpack Gradle project looks like. It's pretty much like anything in Gradle based. So you have the build.gradle file, the Gradle wrapper, so that's Gradle stuff, standard things. And then if you look about the SRC directory, you have SRC main Java or SRC main Groovy, normal stuff. And then there is a special directory called SRC Ratpack. Here you have anything related to Ratpack. Essentially, this is the main Ratpack file where you can put your Groovy DSL, like the example we saw before. And then you can have, if you want, like assets or templates or whatever. And then SRC test Groovy or SRC test Java, whatever you want. So if I open this with IDEA, this is the ratpack.groovy file. So it's essentially the same thing we saw before, but in that file. So let's try to run this. So in this case, I can just say gray.w run. This will give me like a proper Gradle build with output and everything. It started. So now I can curl this. I have like an HTML page. And that's all about the demo, right? So this is really simple. If I run this with Gradle -t, you can see the development time reloading feature. So it's don't see anything with the shell. This is the continuous build. So the server started, and then Ratpack is listening. Sorry, Gradle is listening for changes in your source directory. So, for instance, if I change this title to be something like that. I save. Then I see that Gradle is triggering a restart of the server automatically, right? So you can just call, and JDD will be over here. Well, the most important concept of a Ratpack is the handler. Essentially, when an incoming request is coming, it's passed through a chain of functions. So a handler is a function that can respond to the request. It can delegate to the next handler in the chain, or it can insert more handlers in the chain and delegate to them. So they basically can manipulate the chain. Each handler is given a context instance, so they can interact with the request and response objects. They can access the registry. I will tell you about this later on, etc. So one thing to consider is that Ratpack is not based on the servlet API, as opposed to Spring Boot or anything like that. So don't expect here like the HTTP servlet request or the HTTP session, anything like that. There is nothing about that. It's you have to remember it's Netty based. So Netty is a very basic network library, right? So yeah, you have similar elements in the request and response object, so you can I don't know, read headers, read parameters, everything that's coming from the request cookies, everything you can read with that interface, but this is like a different interface. Okay. We have here a little bit more complex example. So this again is the Ratpack Groovy DSL. Everything I'm showing you is using the Groovy DSL because, well, first of all, I like Groovy. Secondly, is simpler to show this in Groovy. But theoretically, you can do all these things in Java. It's just more code to do this, right? But this is basically method calls, right? And actually, there is a nice code completion feature in IDEA, so there's no magic here. So the handler chain are defining blocks like this one. So inside this block of handlers, I can define all my handlers, and they are interpreted in the order they are defined. So for instance, this guy will execute always, as the name implies. This is not an arbitrary name. That means that particularly we want that handler to be executed always, or for all requests. And this is useful for like things like login or anything else which is something you want to apply to all the requests regardless of the path. You can apply a handler for a particular HTTP method and for a particular path in the request, like this one. You can group handlers by path. So this is like a /API/methods. And then inside here, if the request is a GET request, then you will see this one. If it's a POST request, you will see this one here. You can encapsulate handlers in their own classes, like this thing. So when the no path is requested, this guy will be executed, which is simply a class that implements handler, and there is a handler method. There's nothing else about it. It's just easier to do that as closure, but you can do in classes as well. And this is an example where you can like read elements from the path and fetch them as variables. So let's run this. if I request the default URL, there is a 404 because no handler is responding to that URL. However, if I look at my output, I see that the request has been logged because of the first handler I defined. This guy here, which is printing the request, right? So if I, however, request foo, I get bar. What else do we have here? Like, for instance, API methods. If I don't write the type methods, we have like a get, and then if I send a post request, then we see the post. We have like API now. We have a date and username. We have that output. So that's essentially it, right? There are a little bit more features you can use, but this is an idea to get you how it works to work with the chain. So essentially, you respond to requests based on the path, the HTTP methods, but there are many things like, for instance, the HTTP header or cookies or anything like that. So that's the idea, essentially. All right, that's enough for handlers. The context provides access to the HTTP request and response objects and allows the handler to interact with others using like the next method and the insert method. We saw before the next method here. If you're familiar with the filter API, the servlet filter API, you know that in a filter, if you don't call chain to filter, then your filter is basically terminating the request or the response, right? This is something similar, right? You can actually think of a handler like a mix of a servlet and a filter. So this is basically continuing the chain. I'm telling, okay, whoever next, you can execute. But the context is also important because we can access objects in the registry. So a registry is a place where Ratpack applications and handlers can look for objects. So it's like a place where, for instance, if you want to inject services or you want to inject any other utility classes you like, you can use the context, the registry for that. So let's see the demo. What we have here is we have a handler that will be executed for all the requests belonging to this prefix. Then I read the username from the path. I create an arbitrary object, could be something more complex. And then I'm calling the next method, but instead of being with an empty brackets, I'm calling with a single method coming from the registry class. So this guy will create a single registry with a single object inside. So I'm effectively making this user class available for downstream handlers. Yes. For this particular request. Yes. So this happens on this handler, and then we have two other handlers after that, and those are like the two ways you can use to read elements from the registry. One of the ways is use like a declarative parameter. So if in your closure here you declare these parameters of this type, then Ratpack will try to find an object in the registry of this type and will inject it automatically to you, right? So that's the easiest way. If you have like a class, you can use like the get method, and then you pass the type of the element you want, and then you have the element anyway. Let me see, because I think I have some tests here. Share up. I'm using the version 15. So this is, by the way, how a functional test looks like. With this line here, Ratpack will take care of starting an instance of your application on a random port. And with this line here, Ratpack will give you an HTTP client connected to the instance that is running. So after that, you can just send requests to it and establish assertions on the response. We're using that delegate here. A delegate is a Groovy AST transformation that whenever you're calling a method that is not defined on the class where it's being written, like this one, for instance, I haven't defined any getText method here. Then the method call is delegated to the object annotated with the delegate. So this is like a shorthand to avoid things like test client dot whatever, the test client dot, right? And this is a Spock text, so it's more like similar to JUnit. We can run this. So the tests are passing. There's no magic on this handler chain. It's just for the demonstration of how can you insert elements in the registry. Obviously, for more complex integrations, like for instance, if you're creating a large application, passing a single object maybe is not enough. So you will have to make available like services and like more infrastructure code to your handlers, so they can execute the logic. So for that purpose, you can use Google Use. There is an integration with it by default. So you can use it for dependency injection of your services or repositories or whatever. You can use officially supported modules. Or you can package like your own components into modules and then inject them into Ratpack. So this is the list of the supported modules or the official modules in Ratpack. So you have things like, for instance, metrics or H2 database, or I don't know, Pack4j for authentication, Jackson for JSON rendering. You can use HTTP sessions. You can use Spring for dependency injection. So that's a Spring implementation of the registry. And you can define beans and everything, so there is an interaction with it. Many things, and you can write your own ones. So let's see the next example. So in this example, actually this is not the main class, it's, where are you? This guy. I'm using the bindings section to declare my modules. So in this case, I'm saying I want to bind as a book repository. This is an interface. As a book repository type, I want to bind an instance of default book repository, which is the implementation class. The similar thing as a service. I can use an existing module, like for instance the markup template module, to render templates, and this is a renderer. A renderer is an object that is able to, we can see, this guy is able to render instances of type book, so that will make you able to do things like this. So you can render a book, and then Ratpack will look in the registry for any renderer supporting rendering books, and whatever the renderer code has there, it will work. So we can run this as well. I think there is no test, so let's run this code. I think it's the last welcome. It's 4 or 5. Because it's not post. We have an HTML there. We have a text there. So it's mostly working. Final words about the asynchronous model. The classical approach is a thread per request. So if you think about a servlet-based application, when a request is coming, it will take a thread from the pool. It will run your code, and when your code is done, the thread will come back to the pool. The problem comes when your code is blocking, then the thread will get blocked as well. For such case, applications need like a relatively large thread pool. And well, this is the explanation. So there is an overhead here because we need to manage threads. The threads obviously are consuming memory and everything. So the proposition in Ratpack is different. First of all, the I/O is event-driven thanks to Netty. Which means that it's non-blocking, right? It's not the typical server socket and socket classes. It's the new I/O API in Java. So the handler chain is like a pipeline of asynchronous functions. They can be executed asynchronously. So for that, for all the executions, Ratpack has a small compute thread pool. By default is 4. And it's more than enough to handle like thousands of requests. And when you have to have a blocking operation, there is a separate thread pool for that. Oops, sorry. There is a separate thread pool for that. And you can use, even if you want, libraries like ArcJava or something like that for the asynchronous execution. The interesting thing about this is that Ratpack guarantees you a deterministic flow. So the promises, if you have worked in the past with promises or in anything like Vertex, they are complex because you don't know when are they going to be executed, right? But in Ratpack, you have the guarantee that they will execute it in the order they are defined. So the idea is when a request is coming, we have a thread of the compute pool to work with that request. If the request needs to do any blocking operation, then we give the request to a different pool, right? Like a blocking pool. And then the compute will get free as well, right? And once it's done, it comes back to the original thread to the point where it was started. So that's the idea. You can compose functions. Let's see quickly because I'm running out of time. This is a small example of how it looks like to do asynchronous functions and operations in Ratpack. So there is an API like this blocking.get. And I've written like the number of the order of the print elements. So this guy will execute first, then obviously this one after that, because the operations here are executed asynchronously, right? So this guy will execute first because it's defined first, because this blocking operation is defined first. And this is a small example of composing functions into a pipeline that are all of them asynchronously. So this guy will execute asynchronously, and when the promise is fulfilled, then the result will be passed to this function, and so on and so forth, right? So it's very simple. And we have the guarantee that those ones will execute before those ones here. Let's try to run this. One, two, three, four, five, six, seven. That's all. So that's all from me. So thank you very much for coming and attending to my session. If you have any question, my Twitter handle is Alvaro Sanchez with underscore.